Greetings to everyone. Morning all. So today we are going to study about our Unit 3 Part 2, that is about corrosion. So in corrosion, we are going to study about what is corrosion, what are the causes and effects of corrosion, classification of corrosion, mechanism, factors influencing corrosion, prevention methods, etc. So first of all, what is corrosion? So the deterioration or destruction of a metal by the attack of environment is called as corrosion. Okay? So metals undergo corrosion by electrochemical reactions, whereas non-metals undergo corrosion by chemical reactions. So metals generally have a property, that is, it is very stable when it is present in the form of oxides or sulfides or carbonates, etc. Okay? So they tend to change its state, physical state. Okay? So when it is in the pure form, okay, that is in the pure metal form. Okay, so it is extraction of metal takes place from metallic ore to the pure metal. Whereas pure metal, when it is changed into metallic ore, then it is nothing but called as corrosion or oxidation. So why the study of corrosion is important is because corrosion is deterioration of machines and equipments, right? Because they are made up of metal. Then it reduces the efficiency. Okay. Then the product obtained may be contaminated and may lead to several problems, including health hazards. Then it may contaminate stored food, dairy products, etc. So it may also cause pollution. So that is why we can say that engineering design is incomplete without the knowledge of corrosion. So they should know what is meant by corrosion. Now coming to the theories of corrosion or classification, you can say. So these are classified into two types, that is dry or chemical corrosion and wet or electrochemical corrosion. So first coming to dry or chemical corrosion, it is again classified into three types, that is corrosion by oxygen or oxidation corrosion, corrosion by other gases and liquid metal corrosion. So we are going to now in detail for dry or chemical corrosion. So this type of corrosion occurs mainly by the direct chemical action of the environment. That is by the direct attack of gases such as oxygen, halogen, sulfur dioxide, nitrogen dioxide, hydrogen, H2S, etc. Whatever gases they may be. Then this is a type of dry corrosion. That means there is no moisture present. So in absence of moisture, these reactions take place. First coming to oxidation corrosion. It is brought about by direct action of oxygen at low or high temperatures, usually in the absence of moisture. So at high temperature, all metals are attacked by oxygen and are oxidized, except noble metals like silver, gold, and platinum. So at ordinary temperature, all metals are slightly attacked. So alkali metals like lithium, sodium, potassium, rubidium, etc., and alkaline earth metals like beryllium, calcium, strontium, etc., are attacked very rapidly and get oxidized readily. So metal undergoes of corrosion on its surface. Okay, so metal react with oxygen in presence. That is, metal donates its electrons, that is undergoing oxidation. Then oxide ions are formed by taking up the electrons. Now, oxidation occurs first at the surface of the metal, and a scale of metal oxide is formed on the surface of the metal, and it acts as a barrier for further oxidation. Now, tell me, in mechanism of oxidation corrosion, what happens is the oxygen can diffuse inside the metal, or metal can diffuse outwards towards the oxygen. So which one takes place? So generally we say oxygen diffuses inwards to form the metal oxide scale. But this is not taking place. What happens is Metal diffuses outwards, okay, to react with oxygen to form metal oxide layer. This is because of the smaller size. Then, what are the different metal oxide layers formed? So there are four different types of metal oxide layers formed. That is, first one is stable oxide, second is unstable, then volatile, and then porous. Okay. So stable and unstable metal oxide layers, further corrosion does not take place to them. Okay. Why? Because unstable metal oxide layer, if you take for example, it undergoes decomposition. So further oxidation cannot take place. For stable metal oxide layer, because the layer is very stable in nature, further oxidation does not take place. For example, you can take aluminum, chromium, copper, lead, tin, etc. Coming to volatile and porous. So volatile metal oxide layer, because the metal oxide layer is volatile in nature, it escapes into the atmosphere. Again, there is a further chance of oxidation to take place. Example is molybdenum. Then porous layer. So like iron. So if it is porous in nature, if any cracks are developed or pores are developed, then there is a further chance of oxidation to take place. So that is why in general we say stable and unstable metal oxide layers does not undergo further corrosion, whereas porous and volatile metal oxide layers undergo further corrosion. Then we have Pilling-Bedford's rule. So this rule says that the specific volume ratio, that is volume of metal oxide to the volume of metal, if the volume of metal oxide is greater than the volume of metal, then further corrosion does not take place. If the volume of metal oxide is lesser than the volume of metal, then further corrosion takes place. So this is the rule given by Pilling-Bedford. Okay. If the specific volume ratio is more than 1, then it will be non-porous. So then we have corrosion by other gases. So oxidation corrosion has finished. Now we are going to corrosion by other gases. So depending upon the chemical affinity between the gas and the metal, formation of protective and non-protective layer on the metal surface takes place. See, except oxygen, whatever gases are there, like carbon dioxide, sulfur dioxide, chlorine, H2S, fluorine, have corrosive metal actions on the metals. Right? So, the reaction of the gas with the metal depends upon their chemical affinity. Okay? Then only the reaction may take place or may not take place. For example, silver, when it is reacting with chlorine, it forms silver chloride. Okay? So if the film is non-protective, then it destroys the metal. Chlorine gas attacks tin to form tin chloride, which is volatile, and leaves the metal exposed for further attack. So hydrogen gas attacks steel, forming FeS layer, which is porous in nature. So it depends upon the chemical affinity between the metal and the gas for corrosion by other gases to take place. Okay, so this point you have to remember. Then coming to the third part, that is liquid metal corrosion. So as earlier we have discussed, dry corrosion consists of three parts, that is oxidation corrosion, corrosion by other gases, and liquid metal corrosion. Why are we saying liquid metal corrosion? When this is an example of dry corrosion. Okay. So we are saying that this is a type of dry corrosion and there is no possibility of moisture being there. Right? So liquid metal corrosion is to those types of metals which are liquefiable. Okay, for example, you take sodium, cadmium, mercury. Okay. So sodium metals leads to corrosion of cadmium in nuclear reactor. Okay. So sodium metal is liquefiable in nature and it is very dangerous if you leave it in dry conditions. So it has to be put in a solvent. So sodium metal, uh, it leads to corrosion of cadmium in nuclear reactor. Then you can take another example, that is mercury. Mercury is also liquefied. So mercury in petrochemical industries undergoes corrosion. So these two examples you remember, that is sodium in nuclear reactors and mercury in petrochemical industries. So these cause liquid metal corrosion to take place. So this is about dry corrosion or chemical corrosion. That is, it takes place in dry conditions and it is by the attack of chemicals. So that is oxidation corrosion, corrosion by the gases, and liquid metal corrosion. So these three types are. So we have finished these three types, that is in dry or chemical corrosion. So in next class we'll deal with wet or electrochemical corrosion. So that is the another type of corrosion.